Hi everybody! Today's video is going to be about task 2.5, which is the fifth task from Module 2. In today's video, we are going to be working on the following learning targets. The first one is I can graph a linear function using an equation, a table, or a situation in context. Today we're going to focus on equations in order to graph linear functions. We're going to get ready for that. The second learning target for today is I can identify key features and we're going to focus today on linear equations and interpret them in the context of a problem. Today we're going to really be focused on linear functions and key features of those equations. All right, so the big idea for today is that we have already learned how to graph a linear function by making a table of values. We've been doing that since pretty much the beginning of the year. Today, we're going to learn a new way to graph a linear function. And this way is not going to use a table of values. It's going to use a starting point and the slope of the line. Now, before we can actually do this graphing, we need to learn about slope. Some of you may have learned about slope before, some of you may not. So we're going to do this today as a review or a reteaching of the idea of slope. So here's what we know about slope. The slope of a linear function is also known as the rate of change of that function. And there are a couple different ways that we think about slope. We sometimes think about slope as change in y over change in x. And this little triangle here is the symbol for delta. It means change. Another way we sometimes think about slope is as rise over run, which you may have heard before in other math classes. And the last way that we sometimes think about slope is using an equation, and the equation looks like this: y2 minus y1 over x2 minus x1. Now that equation looks really complicated, but I don't want you to overthink it. It literally just means the second y minus the first y divided by the second x minus the first x. That's what those little numbers mean. They just, instead of writing out the second y minus the first y, we just said y number 2 and y number 1. Now, each of these different ways of thinking about slope has its advantages. And if I'm going to be honest with you, depending on what we have, whether we have a graph, a table, or some points, we think about slope in different ways because it makes it easier depending on the problem. So when you have slope and you have a graph, the best way to think about slope is by doing rise over run. Now here's how you can find slope from a graph. Step number 1 is to find 2 nice points on the graph. So if we look at this graph, we want to find a place where the line goes nicely exactly through kind of the corner of a point. One place where that happens is here. Another place where that happens is here. So you want to look for some points that are perfectly perfect, if that makes any sense. Now, in order to find slope, we're going to do rise over run. So start with the lower point. Rise means how far up do you need to go to get to the next point. On this graph, I would need to go up 1, 2, 3, 4, 5 spaces. So the rise on this graph would be 5. Over, now run means either go left or right. You can go either way. So for rise, we're going to try to always go up, but for run, you can go left or right. In this case, we would go to the right, And going to the right, we would go over 2 spaces. So the bottom number here would be 2. And that's how you can find slope from a graph. Now, if you did go to the left, you would have to make that 2 negative. So positive means you go to the right, and negative means you go to the left to find your slope. Now, let's say I give you a table of values instead. If you want to find the slope from a table of values, it's probably best to use change in y divided by change in x. Now, in order to find the change, we need to just look at the pattern in the table. So if I go from, and you can pick any 2 points you want, I'm going to pick the last 2 points in this table because those are the friendliest numbers to me. If you go from 2 to 4, you are adding 2. If you go from 7 to 9, you are adding 2. So you're always going down the table. To go from 2 to 4, you're adding 2, 7 to 9, you're adding 2. What that means is that we can put the change in y, which is the plus 2, that's the y column, divided by the change in x, which is the left column, and that's my slope. Now, in this case, my slope simplifies because 2 divided by 2 is 1. And whenever you can simplify, you're going to want to simplify. So you're going to want to simplify whenever possible. Now, let's say that I give you 2 points like this. The number one recommendation that I would have is make this into a little mini table. So my table is always going to have x on the left and y on the right. The first point I would fill in is just 1 and negative 4. And the second point that I would fill in is just negative 2 and 5. Once you have that little mini table, you can do the exact same thing we did in this problem. So I would use the idea of change in y divided by change in x. My change in y would be to go from negative 4 to positive 5. That means I would have to add 9. And my change in x would be to go from positive 1 to negative 2. That means I would be subtracting 3. So my slope would be positive 9 divided by negative 3. Now, 9 divided by negative 3 also simplifies, and when you divide those numbers, you get negative 3, so that would be your final answer for your slope. All right, I think the best thing we can do right now is practice this a whole bunch of times to make sure we understand what's going on. So, on the next page, we're going to practice this a whole bunch of times. Before we do that, I want to just make sure you guys are aware that there are really only 4 different kinds of slope. We could have a positive slope, which you'll notice the graph looks like it's going uphill from left to right. There's a negative slope, which means it's going downhill. A vertical line, we say, has an undefined slope. And a horizontal line, we say, has 0 slope. The way that I remember this is I imagine a little car driving on the line. So if I put a little car over here, he would be going uphill. If I put a little car over here, he would be going downhill. This car would not be able to drive on this line. So the reason it's called undefined is because you cannot drive on it. And this car would be driving on a line that is 0 fun because it's no fun just to go on a flat line. So I think about this as 0 fun. And that's how I kind of remember the different kinds of slope. All right, let's practice finding a whole bunch of slopes. So for problem number 1 here, if we want to find the slope, since it's a graph, I would think about my slope as rise over run. Now I'm always going to start at the lower point because I need to rise. So on this graph, that means that I would start at this point right here. Rise would be how far up do I need to go to get to the next point. In this case, it would be 1 space. And run would be go to the right. In this case, I need to go to the right 2 spaces. Since 1 divided by 2 does not simplify unless you make it a decimal, which we never want to do for slope, we always want to leave slopes as fractions, that would be my final answer. For problem number 2, again, I'm going to start at the lower point and I'm going to do rise over run. So I'm going to have rise over run. In this case, if I wanted to rise, I would need to go up 2 spaces over, and now I'm going to need to go to the left. So if you think back to what we said on the other page, I would go left 2, makes it negative. This slope does simplify. So 2 divided by negative 2 simplifies to negative 1. For problem number 3, all you have to say is if it's horizontal, the slope is 0. And for problem number 4, if you see a vertical line, you would just say undefined. Now, one way that you can double check yourself here is that based on this graph, my slope should be positive, and I did get a positive number as my answer. Based on this graph, my slope should be negative, and I did get a negative number as my answer. So kind of knowing whether your slope should be positive or negative can help you double check your answer here. If I give you a table of values, we're going to need to think about slope as change in y divided by change in x. So I'm going to try to choose the friendliest numbers possible. To go from negative 28 to negative 21, I would add 7. And to go from negative 4 to negative 3, I would add 1. Now you can use whatever points you want here. It doesn't really matter. And that's really important, is to realize that it doesn't really matter that if you want to add, if you want to use the bottom 2 points or the middle 2 points, you're going to get the same final answer either way. So if I go up by 7, then that means that my change in y is 7 and my change in x is 1. 7 divided by 1 does simplify to just 7. For problem number 6, I'm going to again think about this as change in y divided by change in x. Now my change in y here, it looks to me like my friendliest 2 numbers. If I go from 32 to 38, I'm going up by 6. And if I go from 4 to 5, I'm going up by 1. One thing I do want to remind you is if you choose the 32 and the 38, you have to do the 4 and the 5. So if I choose like these 2 rows, I have to use these 2 rows the whole time. I can't like mix and match. Okay, so my 6 is going to go on the top and my 1 is going to go on the bottom. And 6 divided by 1 does simplify to just give you 6. If I have a problem like number 7, I'm going to go ahead and make this into a mini table. So I'm going to have x and y as my 2 columns. My x column is going to start with negative 2, and my y will start with 3. And then 1 and 5 will be my next 2 numbers. Now again, for this problem, I'm going to think about it as change in y divided by change in x. My change in my y will go from 3 to 5, which is adding 2. And my change in my x will go from negative 2 to 1, which is adding 3. So my final answer will be 2 divided by 3, which does not simplify because if you did divide, you would get a decimal. For the next problem, again, I would turn this into a mini table. So my first values in my table would be 1 and -4. And my next values would be -2 and -3. My change in y would be if I'm going from -4 to -3, I'm adding 1. And my change in x would be if I'm going from 1 to -2, I'm subtracting 3. So if I make this into a fraction, I have change in y divided by change in x. My change in y is 1, and my change in x would be -3. And if I divide that, I get a decimal, so it does not simplify. All right, now that we know how to find slope, we can actually make a graph by using slope. And this is the last thing that we'll talk about today, is how to make a graph using a starting point and a slope. My starting point does exactly what you would expect. It tells you where to start. So my starting point, I'm actually going to use green, I think. My starting point would be at 1 and then 5, which is right here. 1 is the x and 5 is the y. So I'm going to find the 1 on the x and the 5 on the y, and that's my starting point. Now my slope is going to tell me rise over run. So in this problem, my rise is going to be 1 and my run is going to be 3. So if I want to graph this, I'm going to go up 1 over 3. And once I do that, I'm going to put a new point there. Now I'm going to continue that pattern. So I'm going to go up 1 over 3, put a point. Up 1 over 3, put a point. I can also go backwards. So if I kind of reverse the pattern, I can go down 1, left 3, down 1, left 3, down 1, left 3. And again, this was my starting point. Once I have that, I'm going to connect the dots with a nice straight line. So you can use like the edge of a book or the edge of your ID or the edge of like a bus pass to draw a nice straight line with arrows on the end. For problem number 10, my starting point is -1, 7. And again, -1 is the x, 7 is the y. -1 is here, 7 is up here. So I would start at this point. And then my slope is -3. Now my trick is you want to put this over 1. You are always allowed to put an over 1 if it's just a whole number like that or an integer. And so my rise would be -3 over my run would be 1. So from this green point, I'm going to go down 3 because it's negative. The rise is negative, and then to the right 1. And my next point would be right here. I'm going to keep doing that. Go down 3, right 1, down 3, right 1, down 3, right 1, down 3, right 1. And each time I do that, I'm going to put a new point wherever I land. I could also go up 3, left 1, which is kind of reversing both directions. And I could still get another point that's in a straight line with the other ones. From here, I'm going to go ahead and draw a nice straight line through those points with arrows on the end. And that is how you can use a starting point and a slope to make the graph of a line. All right, thank you guys so much for watching. I hope you have a great day, and I will see you soon for some practice.